Okay, so here's our wrap-up video. I said that we would learn about separable equations today. Started out just recognizing what a separable equation looks like and looking at a couple examples, noting that even if we don't see x's and y's in the whole equation, it's still separable when we consider constants as functions of either variable. We talked through the steps to solve separable equations, and I kind of tried to illustrate it using that general form of a separable equation. But then we launched into a bunch of examples to kind of see it in practice. So we looked at this first example where we found a general solution, which meant that we had an unknown constant in it. We imagined if we had an initial condition, that's what leads us to the problem of solving an initial value problem in which we don't have unknown constants because we get rid of them using initial conditions. Then we looked at Newton's law of cooling, kind of practiced this idea on a word problem. There was a little quirk where we had to solve for the cooling coefficient. And we talked a little bit about how equilibria are points that we never actually reach now that we have functions that show us how we approach them. It's kind of cool. I like that. And then we talked about a different way that you can handle initial conditions in these problems. We looked at it right away using that Newton's law of cooling example by using definite integrals to incorporate the initial conditions. And it took some intermediate algebra, but you never actually had to like sit down and say the initial conditions are this, and I plugged them in to solve for C. So that's kind of something that some people like and some people don't. But we did look at an example where in order to write the integral defined solution to the initial value problem, you did have to be able to use that definite integral approach. And then we looked at a type of solution where you can't solve for y, so you have to plug in the initial condition early and then just accept that you have an implicit solution to your differential equation. And it's fine that that sometimes happens. So in conclusion, I wrote this wrap up right here that kind of says everything that I just said. We learned to recognize the form of a separable equation. That's going to be important as we learn more and more methods. You're going to want to be able to know which type of equation corresponds to this specific method. And then sort of our general approach was rearrange and then integrate. The trickiest part of this section is handling the initial conditions in either of the ways. Either just remember to plug them in and deal with the unknown constant, or deal with it in the definite integral. Especially since this is your first time solving a differential equation and then solving an initial value problem, it's just kind of putting together a couple different things at one time. So it can be difficult. And then we did a couple examples that showed that solutions to differential equations aren't always going to be neat. Sometimes they include integrals in them. Sometimes you can't write y equals a bunch of stuff, and that's fine. So hopefully you enjoyed your first kind of go at solving differential equations. The practice problem for today is going to be to find the general solution to this differential equation right here. So remember, a general solution is going to mean that you have y equal to something that involves a constant. So something plus a constant, or y equal to a constant times something, where that unknown constant you would solve for in an initial value problem. For this particular one, you have your h of x and g of y not quite separated from each other yet. If you're a little lost on how to start, just factor out the y and that should set you on the right path. So go ahead and get started on that, and then we'll see how it went in class.